Let's dive into complex numbers, which are expressed in the form z equals a plus bi. These numbers extend our number system beyond the real numbers we're familiar with. In this notation, a represents the real part of the complex number. This is just a regular number that we're all familiar with from the real number line. And b is the coefficient of the imaginary part. It multiplies I, which is the imaginary unit defined as the square root of -1. This imaginary unit is what makes complex numbers so special. Now, let's visualize these complex numbers on what's called the complex plane, a geometric representation that helps us better understand their structure and relationships. The complex plane has a real axis shown in blue, which works just like the number line you're familiar with. Positive values go to the right and negative values to the left. And an imaginary axis shown in red, which represents multiples of I. Positive multiples of I go upward, while negative multiples go downward. The horizontal axis represents the real part, labeled RE for real. The vertical axis represents the imaginary part, labeled IM for imaginary. Together, these two axes create a coordinate system for complex numbers. Let's plot some complex numbers on this plane to see how this works in practice. First, let's plot 3 plus 2i. We move 3 units to the right along the real axis, and then 2 units upward along the imaginary axis. This brings us to a specific point that uniquely represents the complex number 3 plus 2i. Next, let's plot -1 plus I. Here we move 1 unit to the left on the real axis, since the real part is -1, and then 1 unit upward along the imaginary axis. Notice how we're using both positive and negative values on both axes. Finally, let's plot 2 minus 3i. We move 2 units to the right on the real axis, and then 3 units downward since the imaginary part is -3i. The minus sign affects the direction we move along the imaginary axis. Each complex number has a unique position on this plane, similar to how coordinates work in a regular Cartesian system. The real part determines how far left or right we move, while the imaginary part determines how far up or down we move. This geometric interpretation gives us a powerful way to visualize complex numbers. Just as we can plot points in a 2D coordinate system, we can represent any complex number, a plus bi, as a point on this complex plane. Let's explore how to add complex numbers through both algebraic and geometric perspectives. Complex numbers are essential in many areas